Hello, today we're going to go over the additive law of exponents, but we're going to integrate fractions, which will make it a little more complex. So the additive law says that if you have two of the same bases and the exponents are different, you can keep the same base and just simply add the exponents. So let's do an example. If I had x to the 1/2 times x to the 2/3, this is a multiplication symbol and the bases are the same. Therefore, I know it's x to the 1/2 plus 2/3. Then all I need is a common denominator, so off on the side, I'm going to get 3/6 plus 4/6. So my answer is x to the 7/6. You want to leave your fractions improper because this just starts to look very confusing. Do not make it a mixed number, please. The next one is going to be x to the 1/3 times x to the 4/5. These have an implied multiplication symbol. Bases are the same. And I'm going to simply add my exponents. So I'm going to have x, common denominator is 15. And on the side, I'm going to say that's 5/15 plus 12/15, which makes it x to the 17/15. And that's how we integrate with fractions. Let's make this a tad bit more complicated. Here, there are two different letters. And these are all multiplied together. You can think about that as rearranging it. X to the 1/2, x to the 3/2, y to the 2/3, y to the 4/5. That's by the commutative properties of multiplication. Numerous times we can rearrange that order. Therefore, I can simply add my x's to get 4/2, which reduces to 2. I should always reduce my fractions. And then I get y to the something 15ths. On the side, I'm going to say that's 10 15ths plus 12 15ths. So I get 22 15ths. On my second example, I'm not going to rewrite it. I'm simply going to add. So I'm going to have an x with a common denominator of 6 off on the side. I'm saying negative 3/6. And then I'm going to say plus 2/6 gives me negative 1/6. And y, I'm going to have a common denominator of 15 off on the side. I'm saying 5/15 minus 6/15 is negative 1/15. Those negative exponents are okay for now. Later on, that will change.